This video is going to be a continuation of section 2.1 pre-calculus quadratic functions, and we're going to practice doing a little bit with the quadratic function where you have to write equations, have to find x-intercepts, and show you different methods of things. Alright, first of all, it says find the standard form. Here's our standard form, y equals a x minus h squared plus k. We also refer to it as vertex form. You'll see that the text also wants to call it standard form. There's a lot of different forms that we have for our quadratics. All right, it says that the vertex is 1, negative 2 and passes through the point 3, 6. Here's what we know. If the vertex is 1, negative 2, then this is an h and k value. That's your hk. And the 0.36 is an xy. So we can actually take the information here and substitute into our form and figure out really the a value. That's the only thing that we don't know. So we've got our y is 6 equals our a we don't know. My x is 3 minus my h is 1 squared plus k is negative 2. I'm just going to keep solving this. So 6 equals, we've got 3 minus 1 is 2, 2 squared is 4, so 4a minus 2. It's 8 equals 4a. This concludes that a is equal to 2. So we can write my equation, y equals 2 x minus 1 squared minus 2. There's your complete form for that quadratic. Now when you go back to write your standard form, make sure that you go back and include your y and your x. The only thing that you should have substituted for is your a, your h, and your k. So you have your vertex and then how it opens and how wide the graph is going to be. That's what would be represented. All right, use a graphing utility to graph the quadratic equation. Find the x-intercepts of the graph and compare with the solutions of the corresponding quadratic equation when y equals 0. All right, so what we're going to do is I'm going to show you how to find the x-intercepts by letting y equal 0, and then you can graph them in your calculator and determine them that way as well. When you use your graphing calculator, you will go to the second, calculate, and you would select the 0. These are called zeros because it's when the function is equal to 0, the function being y is equal to 0. All right, let's look at this first example. So if I've got 0 equals negative 2x squared plus 10x, I'm going to solve this for x. And higher powers like this you can factor. If it's possible, I can divide all of these by a negative 2, so it's x squared minus 5x. Okay, I'm going to go ahead and factor this by taking out an x, so you've got 0 equals x times x minus 5, which concludes that my solutions are, okay, my x-intercepts are 0, 0, and 5, 0. Those are the solutions coming from the factored expression, x times x minus 5. If you graph them on the calculator, these might be pretty easy for you to determine since they are integers. All right, let's look at the next one here. So you'd have 0 equals 7/10 times x squared plus 12x minus 45. The 7/10 is just in the way, so if we're going to go ahead and divide by both sides by 7/10 or multiply by 10/7, you get 0 equals x squared plus 12x minus 45. This does factor. You can do parentheses, and it factors to x. The factors of 45 with different signs that add to 12. It's not 9 and 5. But maybe 3 and 15. So plus 15 and minus 3. Those add to your middle term of positive 12, which then concludes that our intercepts are negative 15, 0, and 3, 0. You want to make sure you list your intercepts as ordered pairs. All right, got one more to do. So you have 0 equals 4x squared plus 25x minus 21. In order for us to find them, we're going to try to factor. If it doesn't factor, you could use the quadratic formula to get your solutions. I'm trying to get my factors to add to 25. I'm going to try 4x and x. The signs have to be different, so I can't use 21 times 1, but I might have to use maybe 7 and 3. Here, if I've got 4x times 7, that's plus 28, and then minus 3. That gives me a positive 25. So this indicates then one of my solutions is negative 7, 0. And the other solution, if you set 4x minus 3 equal to 0, you can add the 3 over, so 4x would equal 3, and divide by 4. So 3/4, 0. That is how you find your intercepts. All of these cases, they were factorable. Your other option would be the quadratic formula, and here's the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. And so this also finds your x values. All right, finding minimum and maximum values. You can use your calculator to do this if you put your expression into y1 and then calculate the minimum or maximum. We also, if you have it in vertex form, which is the case here, this is in vertex form, I know that this quadratic is going to be shifted to the right 4 and up 5. What else I know about it is that it opens up. So then this has a minimum value, and that minimum value is the ordered pair there at the vertex. The minimum would be 4, 5. Okay. You can always go through the process to put your quadratic into this form by hand and then be able to identify your vertex. The vertex will correspond to the minimum or maximum. All right, there's another way for us to find that minimum and maximum here, or finding your vertex, because that's really where it's going to occur. And it is by taking, if you've got y equals ax squared plus bx plus c, that's our general form, then if you use the a and b values from that quadratic, you can find the x part of your vertex by doing negative b divided by 2a. And if you evaluate that, you'd be able to figure out your y for that part of the vertex. Let's show you a quick example. If I've got y equals x squared minus 8x plus 4. So let's just find the vertex instead of doing the quadratic completing the square and putting it in a vertex form. So x would equal negative b, so b is negative 8, so that'd be 8 over 2 times a is 1. So I know that the x is 4. So then if you go back and you put 4 in for all the x's, we would have 16 minus 32 plus 4. This would give us negative 12. So I know that the vertex is 4 and negative 12. So that would be my minimum value there. My parabola opens up here, and this would be the vertex, so that's your minimum. So you can follow the formula negative b over 2a to figure out your vertex. Example 7, the daily cost of manufacturing a particular product is given by the function cost in terms of x is 1200 minus 7x plus 0.1 x squared, where x is the number of units produced each day. Determine how many units should be produced daily to minimize cost. So I need to find the vertex, and we're going to find this vertex by doing the x equals negative b over 2a. Negative b over, oops, that a should be down here, negative b over 2a would equal 7 over 2, let's try this again. Before I do all of the information, we want to maybe write this in order. So you've got 0.1 x squared minus 7x plus 1200. Okay, now we're going to do 7 over 2 times 0.1. This result would give us 35. So 35 is the number of units. Determine how many units should be produced daily to minimize the cost. So that is your x value, and that is our solution, 35 units. If you were asked about cost, you'd want to then put that 35 in to the function and figure out what the cost is. Now, how to do this graphically? Graphically, you'll type it into your calculator and calculate your minimum, okay? So you're just using the calculator to do your vertex. Example 8, find two quadratic functions, one that it opens upward and one that opens downward with the given x-intercepts. All right, well, in order for me to write my quadratic, there's a lot of different ways that we can do this, okay? However, the best way is to write your quadratic like this, y equals, on the left side we're going to do the one that opens up. So we'll have a positive a. I can take these x-intercepts, their solutions, and put them back into an expression. So if a solution is negative 2, then the expression is x plus 2. You do the opposite of, you put it back into its expression form. If a 0 is 5 halves, then it's 2x minus 5. You can check that. If you have this factored and your y is equal to 0, do these give you your intercepts? And that is true. All right, if I just want to have this be opening up, then I just want my a to be positive, and it can be any number, so we're going to just keep it as 1. Remember, the number is not going to change the location, it's just going to change how wide it is. So if I just do a positive 1, that will give me my result. So now if I want to do negative, all I need to do is just change it to negative. I can use any number here. I'm just going to keep it simple though. So how I get the x plus 2 and the 2x minus 5 is I take the 0, the solution to it, and I put it back into the form that I was able to get it. So it's like you're working backwards. So trying to find the expression from that 0. All right, last problem here. It says find two positive real numbers whose product is a maximum if the sum of the first and 3 times the second is 42. Find two positive real numbers, so let's call them x and y, whose product is a maximum. So the product of these two is going to be a function in terms of x and y, and we're going to figure out the maximum of that, the maximum. The sum of the first, and so the sum of the first number plus 3 times the second number is 42. Well, when I write a function, I don't want to have two different variables. I just want it maybe in terms of x. So if we want to replace my y here, then I need to solve this for y. Solving for y would be 3y equals 42 minus x, and divide by 3. Y equals 42 divided by 3 is 14, and then 1/3 x. What I can do is I can place that into my function. So I've got x times 14 minus 1/3 x. We can take this right here and we can graph it into y1, and we could figure out our values. All right, so what I would do is, let's go to y equals into your calculator, and you're going to enter the equation, x parenthesis 14 minus 1/3 x, and I'm going to start with zoom 6 for my graph. We can see the quadratic rises coming from negative infinity, but we don't really see where the maximum is occurring. So I want to change my window. I know my window, positive values, so I'm going to go from 0, and since the sum is 42, I think if I do 42, I should be able to see everything that I need. And then as always, if you set your domain, if you get your x's set, you can do zoom fit, and hopefully we'll be able to see the quadratic. All right, calculate maximum. So second, calculate. This is a maximum point. And you just want to make sure that you're scrolled to the left, to the right. Obviously, you could have done the negative b over 2a, but I wanted to show you your calculator one more time. And then I hit enter again, and you'll see here that we've got 21 is the x value. The maximum is 147, but we know that x is 21. And if x is 21, then the y has to be 7. And how I found that is by putting 21 in here for x and solving for y. So 42 minus 21 is 21 divided by 3. All right, there's your two numbers that give you a maximum product. All right, that concludes today's lesson. Page 96 here, this is your assignment for the first or the second part of that first section.